This is the first in a series of videos on Martian geology. Part 1 describes a general theory of Martian geology that shows how several major Martian geologic features are linked, and that these links provide evidence for a major geological catastrophe. Mars captures the imagination more than any other planet in the solar system. No other known planet has as Earth-like an environment, yet they are still very different from each other. However, Mars is enough like Earth that many have expected to find life there, but none has yet been found. Probes sent to Mars have sent back gigabytes of data. This wealth of data has revealed a relationship between major Martian geological features. They are among the largest of their types in the solar system. These geologic features include the Hellas Impact Basin and the Tharsis volcanoes. The relationship between these features is unlikely to be a result of chance, suggesting a cause and effect relationship between them. All this implies a global Martian geological catastrophe. Now let's take a look at these Martian geological oddities. Hellas is the largest impact basin on Mars. It is also one of the largest known impact basins in the solar system. Hellas is basically a crater about 2,100 kilometers in diameter, which is about 1,300 miles. It's also 9 kilometers deep, that is 5.6 miles. For comparison, Hellas is about half the size of the continental United States and as deep as Mount Everest is high. Hellas' center is located at about 70 degrees east and 40 degrees south. The bottom of Hellas is the only place on Mars with a high enough atmospheric pressure for liquid water to stay on the surface. The energy of the Hellas impact has been estimated at about 5.33 times 10 to the 26 joules. This is a blast of 127 billion megatons, which is equivalent to 8.5 trillion atomic bombs the size of the one dropped on Hiroshima. The Hellas impact dwarfs any known impact site on Earth. The famous Tunguska explosion is estimated at about 500 kilotons. The Chicxulub impact is estimated at about 100 million megatons, with a crater that is at most 180 kilometers across. Earth's largest known impact, called the vertiform dome, is about 300 kilometers in diameter. Now, Earth impact sites do provide insight into the results of large impacts. The Chicxulub impact would have put so much dust into the Earth's atmosphere that it is accredited by most paleontologists with killing off the dinosaurs. The Hellas impact would clearly have thrown up thousands of times as much dust into the Martian atmosphere. If the impacting body came from the asteroid belt, the impact velocity would have been about 7 kilometers per second. This means that the impactor's mass was 2.2 times 10 to the 19th kilograms. This mass is similar to the asteroid Juno, with a diameter of about 206 kilometers. Opposite Hellas on the Martian surface are the Tharsis volcanoes. These are also the largest volcanoes in the solar system. Directly opposite the center of Hellas, at about 110 degrees west and 40 degrees north, is the western side of Abapatura's caldera. Abapatura is the largest Martian volcano by surface area. Yet another Martian geographic oddity is the fact that most Martian craters form a hemispherical pattern on the surface. The center of the hemispherical pattern is about 30 degrees west of the center of Hellas, placing Hellas near the center of this hemisphere. The twin rovers, Spirit and Opportunity, landed on Mars in January of 2004. Since then, they have sent back a wealth of data. Both rovers have found that Martian soil is largely volcanic ash. Many of the rocks they have examined are composed of the volcanic rock basalt. The Hellas impact sent a shock wave around and through the planet. This shock wave would have focused on the exact opposite side of the planet from the impact, which is the location of Abapatura. The focusing of the shock wave would have caused cracks in the crust, and given a weak crust area with a pool of magma below it, such a crack would have resulted in a sudden burst of volcanic activity at this point. The cracks would have continued along the area of weakened crust, forming other volcanoes. This is supported by the fact that 4 of the Tharsis volcanoes form nearly a straight line. They are Serenius Thales, Aqueous Mons, Pavonis Mons, Arissa Mons. Mercury shows that this type of effect can occur. Mercury's largest impact basin is the Caloris Basin. It has a diameter of 1,300 kilometers, which is 800 miles. It is about 2/3 the size of Hellas. On the opposite side of Mercury, from the Caloris Basin, is a lineacted hilly area, about 100 kilometers across, which is 62 miles. The crust here was broken into jumbled blocks by the Caloris impact. All this would have resulted in massive amounts of volcanic activity, thus filling the Martian atmosphere with volcanic ash, including large amounts of sulfur. With such high levels of volcanic activity, the ash would have increased the Martian atmospheric pressure to the point where liquid water could exist on the surface. Much of the volcanic material would have formed the volcanic mounts. In Tharsis, the concentration of volcanoes would have caused a pileup of volcanic material, forming much, if not all, of the Tharsis Plateau. Most of the remaining volcanic ash would have covered the planet, becoming a major component of the Martian soil. At first glance, the hemispherical pattern of craters seems hard to explain by the resurfacing of the lightly cratered north. Furthermore, Hellas being near the center of this hemispherical pattern complicates the problem. However, the relationship between Hellas and Tharsis provides a solution. A closer look at the southern dip in the crater pattern shows that it is entirely part of Tharsis, suggesting that the plateau likely covers part of the southern highlands, making them look more spherical. This conclusion is supported by crustal thickness measurements made by Mars Global Observer. The fact that Hellas is on the opposite side of the planet from Tharsis naturally places it near the center of the hemispherical pattern. Also, since the northern lowlands have a lower elevation than the highlands, more volcanic and ejected impact material settled in the north. This is because it is easier for dust to be blown from a higher to a lower elevation. This process would also be aided by the fact that most, if not all, of the volcanism occurred on the thinner lower land crust. The results would be a nearly complete resurfacing of the northern lowlands. In conclusion, Mars has the largest in the solar system of 3 major geological features. Finding this combination of features on the same planet is highly improbable. Finding a relationship between them suggests a cause and effect relationship. Finding the largest crater and volcanoes in the solar system in a cause and effect relationship suggests a major catastrophe.